How to calculate normality in chemistry? Well, I challenge you that you will not find this type of simple explanation anywhere. In this lecture, we will learn the basic concept of equivalent mass and equivalent weight, how to calculate equivalent mass, basic concept of normality, and numericals of normality. So watch this lecture till the end and you will learn something very simple. Firstly, let me teach you the concept of dissociation or ionization of acids and bases in water. For example, consider an acid like HCl and base like sodium hydroxide. Now when we add HCl to water, it breaks down or ionizes into hydrogen ion and chlorine ion. Here, the number of hydrogen ion is represented by X. So X is equal to 1. Thus, in case of acid, this X is equal to 1 means that if we take one molecule of HCl, it will produce one hydrogen ion in the water. Secondly, when we add sodium hydroxide to water, it breaks down or ionizes into sodium ion and hydroxide ion. The number of hydroxide ions is also represented by X. Thus, in case of base, this X is equal to 1 means that if we take one molecule of sodium hydroxide, it will produce one hydroxide ion in the water. Therefore, remember that X represents the number of hydrogen ion or hydroxide ions in the solution. Now let me teach you the concept of equivalent mass or equivalent weight or gram equivalent, which no one is teaching us. Remember that in chemistry, these three terms are the same. Now consider one molecule of H2SO4. I will explain both its molar mass and its equivalent mass. For example, there are 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen are present in one molecule of H2SO4. The molar mass of hydrogen is 1, the molar mass of sulfur is 32, and the molar mass of oxygen is 16. After calculation, I get 98 gram per mole. Now this is the molar mass of H2SO4. Here, if I ask you, what does it mean? Can you answer it? Well, it means that the mass of one molecule or 1 mole of H2SO4 is 98 gram. Let me repeat it. The mass of one molecule or 1 mole of H2SO4 is 98 gram. Thus remember that mass of 1 mole of any molecule is called molar mass. Now what about equivalent mass? Well, to calculate equivalent mass, we need 2 things. I mean, molar mass of a molecule and the value of X. We know that the molar mass of H2SO4 is 98 gram per mole. Secondly, we can see that there are 2 atoms of hydrogen present in H2SO4 which will dissociate in water or in any solution. So the value of X is 2. Now the formula of equivalent mass is molar mass of a molecule upon X. The molar mass of H2SO4 is 98 gram per mole and the value of X is 2. I get equivalent mass is 49 gram. Now here comes the climax of this lecture. If I ask you what is meant by equivalent mass of 49 gram of H2SO4, can you answer this question? Well, let me explain it. Consider 10 bulbs. Let 4 bulbs can light up and 6 bulbs are dead. So we say out of 10 bulbs, only 4 bulbs has the capacity to light up. Let me repeat it. Out of 10 bulbs, only 4 bulbs has the capacity to light up. Similarly, we say that out of 98 gram of H2SO4, only 49 gram of H2SO4 has the capacity to react. Let me repeat it. Out of 98 gram of H2SO4, only 49 gram of H2SO4 has the capacity to react. Therefore, we define equivalent mass as it measures the reactive capacity of a molecule in grams. So remember that Molar mass shows the mass of a 1 mole of a molecule, and equivalent mass or gram equivalent shows the reactive capacity of a molecule in grams. Now let me teach you that how can we calculate equivalent mass of 1 mole substance. Well, consider these substances. We already know that to calculate equivalent mass, we need two things, molar mass and value of X. Now in HCl, there is 1 hydrogen and 1 chlorine. The molar mass of hydrogen is 1 gram and that of chlorine is 35.5 gram. So the molar mass of HCl is 36.6 gram. Secondly, we know that there is only 1 hydrogen in HCl. So the value of X is 1. Now equivalent mass is equal to molar mass upon X, or 36.6 upon 1. I get 36.6 gram equivalent. In case of sodium hydroxide, there is 1 sodium plus 1 oxygen plus 1 hydrogen. The molar mass of sodium is 23 gram, that of oxygen is 16 gram, and that of hydrogen is 1 gram. I get 40 gram. Secondly, there is only 1 hydroxide ion in sodium hydroxide. So the value of X is 1. We know that equivalent mass is equal to molar mass upon X, or 40 gram upon 1, I get 40 gram. So the equivalent mass of sodium hydroxide is 40 gram. In case of sodium carbonate, there are 2 atoms of sodium, 1 atom of carbon, and 3 atoms of oxygen present in it. The molar mass of sodium is 23 gram, that of carbon is 12 gram, and that of oxygen is 16 gram. I get 106 gram. Now here, there is no hydrogen ion and no hydroxide ion. So it is a salt. In case of salt, we consider positive ions. We know that the positive ion is sodium. There are 2 atoms of sodium, so the value of X is 2. The formula of equivalent mass is molar mass upon X, or 106 upon 2, I get 53 gram equivalent. So the equivalent mass of sodium carbonate is 53 gram. Thus by this way, we can calculate the equivalent mass of a molecule. Now let me teach you one very important concept which no one is teaching us, and without this concept, we cannot calculate normality easily. For instance, how to calculate equivalent mass of a substance when mass is given. Well, consider 0.98 gram of H2SO4 and 20 gram of sodium hydroxide. Now to calculate number of grams equivalent in 0.98 gram of H2SO4, I follow 3 steps. I find molar mass, then I calculate equivalent mass, and lastly, I find the number of gram equivalent of H2SO4. We already know that the molar mass of H2SO4 is 98 gram. Secondly, we know that the formula of equivalent mass is molar mass upon X. The molar mass of H2SO4 is 98 gram. So I write here 98 gram. There are 2 ions of hydrogen, so the value of X is 2, and I write here 2. After calculation, I get 49 gram equivalent. Now listen carefully. The formula of number of grams equivalent is equal to given mass upon equivalent mass. We can see that the given mass is 0.98 gram and the equivalent mass is 49 gram. Thus I plug in all these values in this equation. After calculation, I get 0.02 gram. Now listen carefully. If I ask you, what does this 0.02 gram means? Can you answer it? Well, it is simple. I mean, if you take 0.98 gram of H2SO4, only 0.02 gram has the capacity to react. Let me repeat it. If you take 0.98 gram of H2SO4, only 0.02 gram has the capacity to react. Now in case of 20 gram of sodium hydroxide, I again follow the 3 steps. We have already calculated the molar mass of sodium hydroxide, which is 40 gram. Secondly, we know that the formula of equivalent mass is molar mass upon X. The molar mass of sodium hydroxide is 40 gram and the value of X is 1 because there is only one hydroxide ion. Thirdly, we know that the formula of number of grams equivalent is equal to given mass upon equivalent mass. The given mass is 20 gram and the equivalent mass is 40 gram. I get 0.5 gram. Now this 0.5 gram equivalent means that if we take 20 gram of sodium hydroxide, only 0.5 gram has the capacity to react. Let me repeat it. If we take 20 gram of sodium hydroxide, only 0.5 gram has the capacity to react. Therefore, by the help of these 3 steps, we can easily calculate the number of gram equivalent in given masses. If you have learned all these concepts, I congratulate you. You have already learned the concept of normality. Now what is normality? Well, I always teach molarity and normality together. Remember that they both measure the concentration of a solution. For example, if I take 1 mole of HCl and I dissolve it in 1 liter water, I say that the molarity of this solution is 1 m. So molarity is defined as number of moles dissolved in 1 liter solution. On the other hand, consider that I take HCl and we know that its equivalent mass is 36.6 gram. I dissolve it in 1 liter water. So we say that the normality of this solution is 1n. So normality is defined as the number of gram equivalent of solute dissolved in 1 liter solution. Let me repeat it. The number of gram equivalent of solute dissolved in 1 liter solution. Here, let me ask you one of the most difficult question which a lot of students are not understanding. If I ask you, what does 1 normality of HCl means? Can you answer the question? Well, we know that HCl is solute and water is solvent. In HCl, there is only one hydrogen ion and we know that the molar mass of hydrogen is 1 gram. So this 1 normality means that in 1 liter solution of HCl, only 1 gram has the capacity to react. Let me repeat it. In 1 liter solution of HCl, only 1 gram has the capacity to react. So remember that molarity measures that how many moles of solute are present in 1 liter solution, while normality measures that how many grams equivalent of solutes are present in 1 liter solution. Now let me teach you that how can we calculate normality. Well, find the normality of the solution by dissolving 4 gram of H2SO4 in 500 ml water. Here, the given volume is 500 ml. I always convert it to liters. I divide 500 ml by 1000. I get 0.5 liter. Secondly, the given mass is 4 gram. Now we need to convert this 4 gram to number of grams equivalent of solute. To do so, we follow 3 steps which we have already learned in the previous slide. We know that the molar mass of H2SO4 is 98 gram. Here, to calculate equivalent mass, we divide molar mass by X. Here, the molar mass is 98 gram and the value of X is 2 because there are 2 hydrogen ions. After calculation, I get 49 gram. Thirdly, to find the number of grams equivalent of solute, we divide given mass by equivalent mass. Now the given mass is 4 gram and the equivalent mass is 49 gram. After calculation, I get 0.0816 gram. Lastly, I calculate the normality. The formula of normality is number of gram equivalent of solute upon volume of solution in liter. We know that the number of gram equivalent of solute is 0.0816 gram and the volume of solution is 0.5 liter. I plug in these values in this equation. After calculation, I get 0.16 gram per liter or 0.16 N. So the normality of this solution is 0.16 N. Secondly, let me teach you one another numerical. Calculate normality of this solution by dissolving 10 gram of calcium hydroxide in 300 ml water. Here, the given volume is 300 ml. I convert it to liter by dividing it by 1000. I get 0.3 liter. Now I need to convert this 10 gram of calcium hydroxide to number of grams equivalent of solute. To do so, I follow 3 steps. We know that the molar mass of calcium hydroxide is 74 gram. Secondly, to find equivalent mass, I divide molar mass by X. We know that molar mass is 74 gram and the value of X is 2 because there are 2 hydroxide ions present in calcium hydroxide. After calculation, I get 37 gram. Thirdly, to calculate number of grams equivalent of solute, I divide given mass by equivalent mass. We know that given mass is 10 gram and the equivalent mass is 37 gram. So I plug in these values in this equation. After calculation, I get 0.27 gram. Lastly, I calculate the normality of this solution. The formula of normality is number of grams equivalent of solute upon volume of solution in liter. The number of grams equivalent of solute is 0.27 and the volume of the solution is 0.3 liter. After calculation, I get 0.9 gram per liter or 0.9. So the normality of this solution is 0.9. Now let me teach you one important concept of normality and molarity which is usually asked in MCQs. What is the normality of 2M H3PO4 solution? Well, this 2M means that the molarity of H3PO4 is 2 moles per liter or just 2M. Now the relationship between normality and molarity is N is equal to M into X. We know that there are 3 hydrogen ions present in H3PO4, so the value of X is 3. And we already know that the value of M is 2. So I write N is equal to 2 into 3 or N is equal to 6N. So the normality of this solution is 6N. Thus remember this relationship of normality and molarity which is usually asked in MCQs. Finally, let me teach you one advanced numerical. Calculate the mass of H2SO4 present in 200 ml of a binormal solution. Remember that semi-normal solution means 1 upon 2, binormal solution means 2, centinormal solution means 1 upon 100, etc. In such type of numericals, normality is already given. For example, 2N. We know that normality is equal to number of grams equivalent of solute upon volume. Here, normality is 2 and we divide 200 ml by 1000, we get 0.2 liter. After calculation, I get the number of gram equivalent of solute is 0.4 gram. Now I follow the 3 steps. Molar mass of H2SO4 is 98 gram. Secondly, the equivalent mass is molar mass upon X. We know that molar mass is 98 gram and the value of X is 2. After calculation, I get 49 gram. Thirdly, we know that Number of moles of solute is equal to given mass upon equivalent mass. Now listen carefully. We have already calculated the number of gram equivalent of solute, which is 0.4 gram. Secondly, we have already calculated equivalent mass, which is 49 gram. Now if I put these two values in this equation, I can get the value of given mass, which is required. So I put these two values in this equation. After calculation, I get 19.6 gram. So the given mass or the required mass is 19.6 gram. Therefore remember that the mass present in 200 ml of H2SO4 is 19.6 gram. Thus by this way, we can easily calculate the required mass if normality is given. So this was all about normality.